Okay, guys, this video is on how to complete the Galactic Redshift data and graphs assignment. And so if you open up the assignment, there are three different documents in there, and really you only need two of them. So this bottom one is just an explanation of where all this stuff comes from, but I'm going to walk you through that anyway. So this one here, the Google Sheets, is where you will do most of your work, that you will make your graph and then import it. And then this one right here is the one that you will submit back to me. So this is the only document that you will submit back to me. Um, and you should get this done fairly quickly. So I'm going to walk you through it right now. So when you click on the Sheets document, this is the information you are given. At the bottom, you can see there is the Galactic Redshift data tab. That's what you're on right here. You are asked to put the graph into this tab and then the follow-up questions here. I actually took these two tabs out, and that's what you're going to do in this document right here. So these are the questions, and then you're going to insert your graph over here, and I'm going to show you how to do that. Okay. So first, part of the reason for this assignment is again to see the value in using Sheets to do more than just making graphs, but to use it as a calculator, if you will. And so here, the distance in megaparsecs of these various galaxies, we can determine that distance. And that comes from these things called Cepheid variables. And that's, we just don't have time for a full explanation of them right now. But they are a type of stars that allow us to determine the actual distances of stars and therefore galaxies that these stars are in. And so this formula right here is what we're going to enter into this cell right here. And so if we use this formula, we will be able to determine the distance in megaparsecs of these various galaxies. Once we have that information, we will then use a formula to calculate the velocity of these galaxies, and the formula for that is right down here. Now on your Google Sheet, it doesn't have this information, so I'm going to kind of just add to you some information for you right now on that. And so again, anytime you enter a formula in a cell, you start with equals. So I start with equals, and then that's the D equals right there because it's saying distance equals. So D equals, and then I'm going to just type in SQ. And as I start doing that, you'll see it pops up right here, square root. So I'm going to click on that. And so now I have equals square root. It already did the parenthesis for me right there. So then luminosity. And if I come over here, I see the luminosity right here. So I'm going to click on this cell that has the luminosity. And then the next thing is to divide that. So I'm going to hit that slash mark, divided by. And then the next thing is to put in a parenthesis. So I'm going to put that in now. Then after that, I have the number 4. So I enter that number. That symbol right there, that little star, is time. So I hold shift and then hit 8, and that gives me that little time symbol. And then I'm going to enter in pi. So if I type in pi, again, it pops up right there, and I'm going to click on that. And then it automatically does a parenthesis for me, and I can see that here. And then I want to do the closed parenthesis. And then the next thing is to put the times. So I'm going to again hit shift 8. And then I'm going to click on the apparent brightness, and that is right here in this cell right here. So I'm going to click on that. And then I'm going to do end parenthesis, end parentheses. And so now I have my formula, and I can see what looks up here is identical to what is here. And so if I hit enter, I get the number 2. And so that's saying that this galaxy is 2 parsecs away. Okay, so if I click back on it, I can see that there's that little box right there. So I'm going to reach up and grab that and pull it down. And I just calculated the distance of every one of these galaxies. Okay, so now I'm going to move on to the velocity. So once again, I'm going to enter a formula into this cell. So again, anytime you enter a formula, you always start with, yep, equals. So the velocity equals, what does the velocity equal? The velocity equals the peak hydrogen emission line. Okay, so I have to do 2 parentheses first. So open parenthesis, open parenthesis. Then the peak hydrogen emission line. That's this number right here. So just a quick little segue here. Remember that the peak hydrogen emission line should be at 656.3 nanometers. In a laboratory, if we were to uh, run a current across hydrogen and look at it through a spectroscope, we would see a peak line at 656.3 nanometers. But because the galaxies are moving, the lines are shifted and they are predominantly red shifted, so the number will be greater than 656.3. The greater the number, the more it's shifted. Now this first galaxy you'll notice is less than 656.3. This galaxy is actually blue shifted, so it is actually coming towards us, and because it's coming towards us, the velocity should be a negative number. That's what a negative number is going to indicate, that the galaxy is moving towards us, and a positive number will indicate the galaxy is moving away. Okay, so I come back over here and I see that's my peak hydrogen emission line. And then I'm going to hit minus 656.3. So minus 656.3. I'm going to end parenthesis. So shift 0 to end the parenthesis. And then I'm going to divide it by 656.3. So divided by 656.3. And then I'm going to end the parenthesis. And then I'm going to hit times the shift 8. And then I'm going to enter the number 300,000. But be very careful here. I have a comma right there. You cannot put a comma in the formula. If you put a comma there, it'll give you an error and you won't be able to get the right answer. Okay. Um, and then if I hit enter, it'll say autofill and I'll say sure. Check mark, and it auto-filled all of them. And you'll notice that all of the galaxies are positive with the exception of the first one and the last one. And the Andromeda galaxy is actually moving towards us at a pretty high rate of speed, 247 kilometers per second, but it'll still take billions of years before we collide. Okay. I just want to come over here for a quick second and just call your attention to this, because this is exactly what you guys did for the galaxies A through D and the other activity. And so if I call this back up, you'll see that what did we do? We identified the difference in the hydrogen emission line. We then took that as a percent by dividing by 656, and then we multiplied by 300,000. And that's exactly what you're doing in this formula right here, and that's where these velocities come from. Okay, so once you have that right there filled out, you're going to make your graph, and you do that just by highlighting the two columns and clicking on insert chart, or you can come up here and hit insert and then click on chart. And this is what I get here. Okay, and again, it should be a scatter chart, so make sure that if it defaults to a bar graph or something like that, you click on scatter chart. And then I want to make some changes here, so I'm going to come to customize. Once again, I'm going to do most of my work under the series right here. So I'm going to click on series. I'm going to scroll down. I definitely want a trend line, and it is indeed linear. I'm going to come down. I want to show my R squared value. Under label, I want to make sure I show my equation. So use equation, and you'll see that I get this equation 79.9 times x plus a negative 166. So remember, this is an mx plus b because this is a linear trend line. That m is your slope, 79.9. Remember that slope is rise over run. Your rise is your velocity and your run is your distance in megaparsecs. So there is a question that's going to be asked later about what the meaning of this slope is. So 79.9, what would your units be? Okay. And then the other thing that we haven't done much of that I want to show you is that you're going to add error bars. So right above trend line, if you click on error bars, it'll default to 10%. Okay, so it gives a 10% error, and that's going to become important later on. Okay, so here's our graph, and that's all you need to do with it. So I'm going to hit Control C to copy that graph, because when we come to this other, so again, remember under here, this one right here is what you're going to turn in, and I'm going to come over here and it says, click on Insert, go to Drawing in the drop down, click on New, paste in your graph into the drawing. So if I click on insert, well, I'm going to actually do it under here. If I click on insert and go to drawing and go to new, I can hit Control V, and I would paste it unlinked right now and then hit paste, and there's my graph. Now it's going to ask you to do a minimum and a maximum trend line. So the way you're going to do that is just come over here where it says line, and then you're going to kind of start off at the zero and go to the tops of your highest error bar. So right about there. And then for the minimum, you're going to start down below and you're going to go to the bottom of your longest error bar. And so this is really our margin of error in here. And so remember that that the default was a 10% error as it plotted this. And so this is based on a 10% error either way. Okay, so if I hit save and close, there it is. Okay. And then it just asks a series of questions on that. The meaning of the slope. So remember, we kind of covered that. That's this number right here. The value of the slope of your trend line, including units. So remember, rise over run. So here's your units. Okay. What is the margin of error? That was what I just alluded to a minute ago. The expected velocity of a galaxy 12 megaparsecs away. So again, here's your distances. Use the actual trend line when you're trying to determine those things. And then you're going to write a brief CER regarding the state of the universe. When I say state of the universe, I mean, what do we know the universe is doing, and how does this provide evidence that the universe is doing that thing? Okay, and that's it. Thank you.